Well, this is the chemistry lessons. Roughly, I'll be demonstrating you the states of matter. If you like to explain some of the difficult concepts, like for example here the energy within the different states of matter, and also we like to show the different relationship between the pressure, energy, and the movement of the particles and its force of attraction. This is quite simple that if you use the animations, you can teach both the practicals and theory. The state of matters that begins from the even from the primary level, and we see same concepts goes as high as class 12. And in the class 12, I know the complex will be the concept will be a little bit complex, right? This is where you can show for lower classes what would happen if we change the energy of the system, and what will happen to the solid particles. These are the what are different particles that we can see in the matters. So these are the matters of, if you look at here, atoms and molecules, you can see the, just now we are looking at the neon, you can also see argons, you can see oxygens, you can see water. And maybe you would like to right now, if you say this is a solid, all right, we are looking at the solid state of all this matter. You can also look at this temperature, would be a different for different substances. Look at this, 43 degrees Celsius, Kelvin, and this is 27 Kelvin, and water has got 146 Kelvin. That time this remains in a solid state, and this is useful for the children, especially for lower classes, right? If you go to liquid, this is in water, and water remains in the liquid form at the 286 Kelvin, or if you would like to say a degree Celsius, it's the 13 degrees Celsius. Oxygen remains in a liquid form at minus 260 degrees. Similarly, the argons remains a liquid form at a minus 187 degree, and this is neon at a minus 246. If you like to see gas state of neon is in minus 270 degree, and similarly the argons minus 84, oxygens minus 160, and water remains in a gas state at 156 degrees Celsius, which means it need to be heated, all right? So for the lower classes, this is how you can show them a difference and allow them to move this heating system. If what happens to the solid if we heat, let's go to solid of the neon, what happens if we heat this solid, and if you allow to apply heat on the system. See there, look at the temperature, it has become minus 200 and its temperature is increasing. Temperature has increased, now it has become 192, and then temperature keeps on increasing. Just see that I have applied the heat by moving this, all right, this button. I'm moving this button and temperature is being increased, all right? And what happens here? Now if I ask the questions, what happens to these molecules? They go far apart. And this is very interesting, for especially for lower classes. So just what you have to do is apply heat and see the different states of matter and see the temperature. This is particularly useful for the lower classes. Let's look at little higher class, right? I will bring now, this is for little higher classes. Look at this, there is where you can increase and decrease the temperature. You can see this temperature reading here. You will see the this is pressure reading here. You will see temperature reading here. You can apply pressure from here. You can also apply molecules, add more number of molecules from here. So you can you have a lot of variables here. What happens, you can see what will happen if the temperature increases, what happens to the pressure. And you can also see there is a relationship on the graph, distance between the atoms and also the potential energy. If potential energy increases, what happens to the distance between the atoms? Similarly, these phase diagram which you have been teaching in class 11 and 12, those of you who already taught knows about this. There are different phases. solid phase, liquid phase, and gas phase, and what happens to the temperature and pressure. With the change in temperature and pressure, there is a change in the different phases and their interactions. This is what we are going to look at a higher level. And for this, as simple as I would like to just show you how to handle some of the parameters. What happens? Just look at this. What happened? I'm adding additional molecule. I'm adding additional molecules to it. What happens if I do that? If I add number of molecules to the system, definitely pressure will increase. Had it been noted the temperature, you would have also seen some change. Sorry. You would have noted the temperature, and probably it has increased. So now there is an increase in temperature and increase in pressure. Sorry. Now if you like to apply pressure from here, you may like to see this applying pressure. You can apply the pressure, you can put the pressure, see there, alright, you are applying the pressure. If you apply the pressure, what happened to the temperature? Have you noted down? Please look at that pressure meter as well as temperature meter, alright. See their temperature, okay, is 800 degree Kelvin. Pressure is crossing now 100. See there, see, okay. You can go back. Otherwise, if you keep on pressing, it will just lead will go off, because of the high pressure. And also you have seen there is a red dot reached here. Now please refer to this side, to this red dot, and what happens with if I decrease the temperature to 0 degrees Celsius, okay. Look at the pressure and temperature, both are decreasing. And also you can refer to the red dot, what happens later, alright. Once this temperature really comes down, it's coming down. Look at the red buttons on the other side on the graph, it is also coming down, alright, and it will come down. You will know what its state it is. The matter is in the state. So this is why it's called the different phases. Look at this, right? So now you see this red dot has come from here to here 0. Well, the temperature comes to 2 Kelvin, pressure becomes 0, and everything is now settled. What we are doing is we are trying with the neon. You would have tried very well with the water. You can try with any of this element. Alright, now further, if you want to see the attractions of the elements, atoms between these two atoms, what are the different types of energy and the force of attraction, that we have already talked about. The force of attraction, Van der Waals force, repulsive electrons overlap, some forces exist between the atoms. This is what we are going to look at this on the graph. So it is quite interesting. You can play with this, just apply this force and then see what happens. This is a repulsive force, and then this is how the atoms are pushed far away from each other. Although they are attracted by some force, while there are some force which will repel as well. Okay, so this is how you can play with. There are option for you to take it to higher classes or take it to the lower classes and show them that how molecules behaves with changing temperature, changing pressure. So this relationship can be taught very well using this kind of simulation. This lesson is particularly useful for the chemistry, and similarly we have a similar kind of simulations in biology, in chemistry, in physics, in mathematics. This is all to know about this is one thing. If it is a practical, this is to collect the data, and if it is a theory, it is very easy to understand the very, very, very complex concept through practice, through hands-on, right? This is what is the advantage of the simulation. Thank you.